The next step is to draw the original ground profile starting from A, 1, 2, 3, etc. up to cross-section B, which is the end of the project. So let's start from the first one. 54 is the elevation of the original ground at the projection of the center line for the first cross-section, 54 meters. I know that the datum line in my datum line is 53 meters, so there is only 1 meter difference between the datum line and the first point, 1 meter. I'm going to draw a vertical line which is in length 1 meter when the ortho is on. 1 meter, be careful, in 1 to 200 scale is 5 units, so type in 5. Okay, so this is a 5 unit long line which indicates the elevation of 54 meters at the top of this line. Let's do the second one. 55.20. Okay, 55.20. First of all, I need to draw a line exactly 25 meters away. Okay, so that distance is 25 meters in real world. Because this is 1 to 2000 in the horizontal scale, it's only 12.5 units. So 12.5 units in real world is 25 meters. Okay, so from this point upwards, 55.20. 55.20 55.20 minus 53 is my datum line, that is 2.2 meters elevation gap. In my scale, times 5, 11 units. Okay, so I draw another line when the ortho is on, 11 units upwards. That's it. So I can delete this now. Do the same thing for the next cross section. Let's do that. First of all, let's indicate the point where we should start the line. 56.71. 56.71 minus 53 always times 5. 18.55. 18.55. 18.55. Okay, and then you can delete this line. That's it. So you repeat the same procedure for every cross section. Then we will draw the profile by joining the tops of these lines with a polyline, as I will show you in a minute. Okay, in the meantime I have continued to draw these lines. The length of each line is the elevation of that cross section minus the datum line elevation in the correct scale. The next thing to do is using the polyline command to join the top of this line with the top of the next line, like that, until the end of the project, that is point B. Okay, so you do this, you do the same thing. Be careful. I made a mistake here. Anyway, so you repeat the same procedure until the end of the project. Carefully, you should click on the top. Okay, not any other point, just the top of these lines. The length of these lines are critical. Okay, continue until point B. Okay, I have updated the diagram, as you can see here, with the elevations of the cross sections for each cross section. The next step is to choose a correct grade line, final grade line in red color. So to do that, you can use polyline again. Click on the beginning of the project and somewhere in the middle, that doesn't matter, then the end of the project. Then assign a proper layer for this. By holding in the middle, you can move around this until you are satisfied with the grade. There are certain criteria that you need to meet. We've discussed this in class. I'm not going to repeat that again. So you remember when we discussed it in class, we said that first of all, the grade of each arm of this profile, I mean this one and that one, there are two arms here. This is in the middle, left arm, right arm, should not exceed the maximum allowable grade that is specified in your coursework brief. In my case, it is 8%. So this arm, for example, should not exceed 8%. Also, this arm should not exceed 8%. Everybody's topography is different, therefore sometimes you might have a summit curve or sag type curve, depending on everybody's depending on your topography. In my case, looks like it is going to be sag type vertical curve if I want to have only one curve here, or I might have two curves actually. This is also possible. So the second thing is to observe earthwork quantities so that cut and fill must be equal to each other, must be close to each other. Cut volumes and fill volumes must be close. Also, in the third criteria, as the third criterion, the vertical curve that you're going to place here must be in negotiation with your already located horizontal curve. We've discussed this in class. It must be either outside your horizontal curve by 60 meters, or their point of intersections must coincide with each other. In my case, if I want to put a vertical curve here, I need to be careful about my horizontal curve. I have a horizontal curve, as you can see here. Let me indicate the beginning of my horizontal curve and the end of my horizontal curve. Okay, so this is the beginning of my horizontal curve, this point, and this point is the end of my horizontal curve. If I want to put a vertical curve here, I need to be careful. Either, let me draw again. Okay. So, either the end of my vertical curve, the distance between the end of my vertical curve and the beginning of my horizontal curve must be greater than 60, or the distance between the end of my horizontal curve and the beginning of my vertical curve must be bigger than 60, or their PI points must coincide. So where is my PI point for the horizontal curve? This is the midpoint of my horizontal curve. Ortho is on. Okay, so this is this line shows the PI of my horizontal curve. So I should place